Welcome back to Max lecture series. In this series we are learning how to obtain the solution for first order linear differential equations. So far we understood if the given equation looks like in the model of Leibniz linear model, then we know how to bring the solution. Suppose if the given first order differential equation can be possible to bring if you are able to segregate all x terms one side, all y terms one side, then it is very easy to solve. That is called variable separable method. Now you know how to obtain the solution in terms of variable separable method and a linear Leibniz model. Suppose, sir, some differential equation is given to us and you are unable to bring the solution by using the previous two methods like Leibniz linear model and variable separable method. Then what shall we do? In that case, cross check whether it is given in the form of the equation that is displayed on the screen. See there. If you observe the given equation, it's a question. From this question, we will try to understand the one more next method. If your equation is not able, if you are unable to solve the equation with the help of the previous two methods, variable separable method and Leibniz linear model, then try with this one. The given it is the necessary and sufficient condition for the differential equation of the form of m of x comma y into dx plus n of x comma y into dy equal to 0 to be exact is. What is the condition here? The thing is, first you have to understand, if you are given differential equation in the form of, see there, something in terms of x and y, some equation will be existing here with the dx. In terms of x and y, some equation will be existing here with the dy. This x and y might be some differential equation like some differential representation, x square y, x cube y, something will be appearing there. If something is there with the dx, you can call it as m. If something is there with the dy, you can call it as n. Now take m, differentiate m with respect to y, differentiate n with respect to x, cross check whether both are equal or not. If this condition is satisfied, then directly you can take integration for this given equation, you will be getting the solution. That's all. So this is the another format. Did you understand anything? Let us take one example and I will be teaching you from that. See there, the question is dy by dx equal to minus 2x by y represents a dash. Whether this above equation is a straight line or it is a parabola or it is a circle or it is an ellipse, we have to identify that. What I am doing is, you can try with some other methods also. Suppose if you are feeling that this equation can be solved with the help of variable separable method, you can try that one. But here I would like to teach the new method. If you are unable to solve some equation with the help of variable separable method and a Leibniz linear model, in that case you can go ahead with this method. Okay. The thing is, some equations can be solved in all three models. Remember, you can apply all methods for some equations. In that case, you will be getting the same answer in all methods. Don't be bothered about it. You don't need to think which method I have to apply. If you are able to apply all methods to any equation, you will be getting the answer, obviously. Okay, sir. So here I am trying to solve this equation in the new method. See, I am just trying to bring this equation into this format. I am just checking m into dx plus n into dy format. Let me do that. Actually, the given it is dy upon dx equal to minus of 2x by y, minus 2x upon y. After that, immediately in the next step, I am just passing this y to the left hand side, dx to the right hand side, such that it can be rewritten as y into dy equal to minus 2x into dx. After that, what I am going to do is, I am planning to bring this equation to the left hand side. If I will do that, then I will be getting 2x into dx plus y into dy equal to 0. I am writing it in terms of addition. After that, see there, now this equation is existing. M into dx, n into dy. Here, m can be considered as 2 times of x, n can be considered as simply y. After that, in order to proceed this third method, you have to cross check whether these two equations, if I will differentiate m with respect to y and if I will differentiate n with respect to x, If these two values will become equal, then I can directly take integration for this given function. That will giving us the solution. Let us see whether these two values will become equal or not. See, if you differentiate m with respect to y, what you will be getting? Can you please tell me the answer? If you differentiate m with respect to y, since if you observe m is having only x, if you differentiate it with respect to y, resultant value will become 0. Similarly, if you differentiate n with respect to x, if you observe n is having only y, so differentiation of n with respect to x will become 0. Since both are giving same result, yes sir, both are giving 0. It means this above equation can be solved directly with the help of, see there, in that case this is called exact solution. This method is called exact solution. So what you can do is directly you can take the given expression. What is the given expression? 2x into dx plus y into dy. See there, let me rewrite 2x into dx plus y into dy. Just to take the integration and equal to, while taking the integration always one constant will be added. Add that constant in the right hand side. In the left hand side you will be having this total equation, in the right hand side you have to add the constant, don't forget that. After that, see there, you can break the integration separately. Now you can do the integration for x separately and for y separately. Tell me what can be the expected answer now. From this I can say integration of 2x with respect to dx will become 2x power 2 by 2 plus integration of y with respect to dy will become y square by 2 equal to constant k. From this, these two will get cancelled out and we will be getting, 1 minute, yeah, we will be getting x power 2 plus y power 2 by 2 equal to constant k. What is this? Now please tell me. Anyway, this is going to be the answer for the above equation. That is how we are obtaining the resultant expression for the given equation in terms of exact solution method. So what you have to understand is, step number 1, you are observing that the given equation is not able to, we can't solve the given equation with the help of linear Leibniz model and variable separable method. Then you are trying that whether this equation can be possible to written in this format. In this format means the one that we have tried now, like this. See there, m into dx plus n into dy format. Then you have to treat whatever the functions that are existing in front of dy, that will be treated as n. Whatever the functions that are existing in front of dx, that will be treated as m. After that, collect m and n variables separately, then differentiate m with respect to y, differentiate n with respect to x, cross check whether both are becoming equal or not. If they are equal, then directly take the resultant expression that you have already written here, integrate it on LHS side, on the RHS side just add one constant, just complete the integration, you will be getting the solution. This is very simple, you don't need to think too much. Just one and only thing that you have to do is you have to check whether this condition is satisfied or not. That is what they have asked in the previous question. They have asked in order to obtain the exact solution when the equation will be given in this format, what will be the sufficient and necessary condition. See there, the necessary and the sufficient condition in order to obtain the exact solution when the equation will be in this format is dash. What is the condition? Dou m by dou y must be equal to dou n by dou x. That is the condition. That is the previous question. Anyway, now we have to identify whether the resultant expression will be a straight line or a circle or a parabola or a ellipse. See, this given equation I am telling it is ellipse. Because see, I am giving one homework question. Try to recapture all type of equation. Parabola, representation of equation. In terms of equation, how can we write parabola? How can we write ellipse? How can we write circle? How can we write straight line? You have to recapture those things because these type of questions will be repeated often from here. From differential equation, they will be asking you often. So this is ellipse. Some of you might be knowing, some of you might not knowing this. Just recapture once. If a equation will be given in this format, x square by a plus y square by b equal to c, that will be simply considered as what? It is an ellipse equation, right? So I am just treating, see, x square by 1, y square by, that is a by x, y square by b equal to c. it is an ellipse equation. In the same way, recapture all other things, parabola, how to write down the parabola and other equations at all. Okay, this is all for this lecture. In the next lecture we will be coming up with one more question. Thank you all.